configuration of actinide from element actinium to lawrencium, that is atomic number 89 to 103. Now if you will see this modern periodic table in group number 3rd B, or you can say third, and period number 7, there is one element which is located is what? Actinium. But along with the actinium, you will find there are 14 more elements placed, and these all 14 elements are called as actinide series or actinides. So basically, if you will see the general electronic configuration of F block, that is N-2 F1 to 14, N-1 D0 to 1, and NS2, where N-2 F is called pre-penultimate shell, N-1 D is called penultimate shell, and NS2 is called valence shell. Since all these three shells are incompletely filled, these all elements are also called as inner transition element. Basically, actinides are referred as second inner transition element. But in case of actinide, if you will see, the value of N is what? 7. So if I am substituting N is equal to 7, so it will become 5F1 to 14, 6D0 to 1, and 7S2. If you will see, the filling of 5F electron involved after filling of 6S, 6P and 7S orbital. Hence, for all these elements, the nearest noble gas we are taking is what? Radon. If you will check the radon electronic configuration, then the last electron in case of radon enters into 6p orbital. So if we are writing electronic configuration of actinide, then the very first column, that is element that is consisting of actinium to curium. Second column is what? Atomic number, and that is consisting of 89 to 96. As I showed you, these all element gives two different type of electronic configuration. The other is expected or ideal electronic configuration, where if you will see up to actinium and curium, if you are discussing, then according to Aufbau principle, electrons are filled in different orbitals in the order of increasing energy level. I mean to say, 5F level start filling after completing of 6p, 6s and 7s orbital. Means, if you will see, the next noble gas or dearest noble gas we are taking for all these elements is what? Radon. In their valence shell, if you will see, they all are consisting of 7s orbital. In their pre-penultimate shell, if you will see, they all are consisting of 5f orbital, and in their penultimate shell, if you will see, they all are consisting of 6d orbital. Let us discuss the configuration of actinium. In case of actinium, actinium does not consisting of electron in the 5f orbital. So actinium is having configuration of 5f06d17s2. Since actinium is not consisting of 5f electrons, so it cannot be taken as F block element. It is taken as transition element or D block element. But after actinium, if you will see, the atomic number of all these elements increases by 1 unit. So now the electron will enter into 5f orbital, keeping 6d and 7s orbital constant. I mean to say, in case of thorium, there is increase in 1 electron. Similarly, in case of protactinium, increase in 1 more electron. So the electrons are continuously increasing into 5f subshell. In case of uranium, it is 5f3, neptunium, it will become 5f4, plutonium, it will become 5f5, americium, it will become 5f6, and finally curium, it will become 5f7. Now these all elements, if you will see, they have also shown different electronic configuration. This is due to the spectral analysis, which shows little deviation from the ideal or expected electronic configuration. For this, if you will see, first we have to consider rule of extra stability, as we have discussed earlier. All the atom and the ion which are consisting of F0, that is vacant orbital, F7, that is half filled orbital, and F14, that is completely filled orbitals, have extra stable state. So if I am talking about three elements, that is actinium, curium and lawrencium, they do not change their electronic configuration. So in case of actinium, the ideal and the observed configuration is same. Similarly, in case of curium, if you will see, ideal and the observed electronic configuration is same, means they have extra stable state. But in case of thorium, if you will see, 5f electron is shifting from 5f to 6d. This is due to the make it more stable. But in case of some element, for example, protactinium, uranium, neptunium, up to this element there is no change in the configuration. This is due to the very small energy difference between 5f and 6d orbital. I am repeating again. In case of protactinium, uranium and neptunium, there is no change in the expected configuration. So their expected and observed both configuration are same. But if you will see, in expected or idealized configuration, the single electron in 6d subshell is retained. But when we are writing observed electronic configuration, the single electron shifts into 5f subshell. For example, except actinium, curium and lawrencium. If you will see in case of plutonium, the d electron shifted from d to f and d becomes vacant and f is increases by 1 unit, which is more near to what stability. In case of americium, the same thing happens, that the d electron gets shifted from d to f, then f becomes 7, which is half filled and more stable. So this is all that we are talking about the electronic configuration of actinium to curium. Thank you very much.